Hi, everyone. Welcome to our final session of the day here on CloudX main stage. I am excited to introduce our speaker. He is Anuj Tyagi, Senior Site Reliability Engineer at Ring Central. And please give him a warm virtual welcome for closing out our stage today.
All right. Thank you, everyone, for joining. So the talk is more about uh, building something like a plugin for Terraforms. If anyone have used Terraform before, uh, it's more centric to people who have used Terraform. It's about building kind plugins for Terraform, which are called provider. So here I am, and good afternoon and good evening to everyone. And I recently did an open source contribution to one of the Terraform provider, and from my experience, I uh, thought to share some of the experience or learning with you if someone else want to do similar or want to build a Terraform provider. Okay, so to begin with, uh, as the as I was introduced, I'm a senior at Ring Central. I'm also AWS community builder, uh, and I provide mentorship to DevOps people to grow in their career. I'm an open source contributor to a couple of cloud native products, or you could say like tools. And I did grad from Northeastern past. So what is Terraform? What is a big deal about it? Is it's a infrastructure as a code tool in summary, and that we can say it makes life easier for people who are SRE or like DevOps people, whoever want to manage their infrastructure with code through can do it through Terraform. And why is it a big deal? It has 36% almost market share in the infrastructure as a code, and so it's used a lot along multiple cloud essentially, and can be used in on-prem and like for building every service or uh, like database. You can build, uh, you can manage your own products internally also with Terraform if you want, but or customer want to manage what they want to use your product, so they can use Terraform also to deploy that. And essentially it's used by more than 2000 organization, as I found from a survey. It could be more, but which is a big thing. So since it's used a lot, learning these kind of things like learning provider for Terraform is definitely useful. So when we are saying again and again Terraform provider, uh, what is, how does it matter? So if like anyone has used this before, so when we use Terraform to manage any of the service, like for example, if you want to deploy any service or on AWS cloud, for example, which is mostly used. Terraform provider has more than 5 billion downloads. So we mention it use abstraction kind of a language called HCL on the user side, and we call providers using that. We provide the version of the provider we want to use, and we give the URL of that, or the registry URL, like it mentioned here, and yeah, if there is any authentication required to manage that service, for example, you want to deploy a database, so you may need to authenticate or maybe add some authentication or something like that. So it depends on service. So that kind of a small snippet you give, then you define what all the configuration you want to give in the on the Terraform for the resource you want to build, right? And on behind the scenes, it's basically calling your APIs. through your provider. So it's like a translation layer that is converting your Terraform templating kind of a configuration into API calls behind the scenes. And that is like extending capabilities, making it better, making it more manageable to manage your infrastructure that way. Then you can do it through a script, right? So what are a little bit more about those providers, like I said, plugins for every different service. They have a registry, Terraform, which is called Terraform registry for providers. Similarly, if someone has used those containers and they use a lot in Kubernetes, and there are different image registry for to use the containers like Docker Hub and similar to that, and there are a lot of other image registry, public or private. And Terraform has this own Terraform registry for providers. So, for example, I just added a small screenshot here from the provider. Like here you can see AWS Cloud Control, Active Directory from Azure has their own provider. So to manage all those, you can use it, right? They're that specific provider you can use, and they are separate binary from Terraform. So every provider has a separate binary, and it's built in Go. Okay, and whenever we want to download it, we define that in Terraform template, and we download it through Terraform init. Okay, so initially I'm just giving a high level background, and then we'll go deep into the provider framework, how we build that, and and how the overall the communication flow works with the binary of Terraform only, that we wherever we download we want to use the Terraform. It's called Terraform core in the Terraform language, and we wherever we can run Terraform commands like Terraform init, plan, and apply. It's used a lot, and then when we are defining that provider definition, the version, and the URL, uh, it, and we define the resource for it, and then we run initially Terraform init command to pull that resource. So it'll pull that binary into your space where we are running your Terraform core, and it will download that binary to through the RPC call. But behind the scenes, we are downloading that Terraform provider. It is when we are going to execute the provider, you're going to use the API calls, the Golang code that or Go code basically in Go is a programming language, and on which the provider and Terraform both are built on, and it'll going to use behind the scenes the client library. For example, if you have, or maybe you're using any AWS service for this purpose, it'll going to use those border library, and those using the API client that is essentially communicating with your target resource or service that you want to create, right? So okay, so uh, about Terraform core. So like we saw here, Terraform core, provider, these are all communicating, and a little bit more about Terraform core. It's so in that way we can see it's like an entry point for a user who are using Terraform, and it is from our perspective who is using the Terraform. Terraform is only managing the resources, and on the provider side, there are binaries that talk to uh, Terraform core or RPC call, and it here we write the code to define for creating, deleting, or updating the resources of the service, right? So we when we execute so provider when we are calling and executing, it runs a provider server, which is the entry point for Terraform provider also. So for us, Terraform core is the entry point, but for provider, Terraform provider server is the entry point. And think of it as like it create a handshake with the Terraform code, and and yeah, so it creates a gRPC call, and there's and I'll show a snippet how we define. So initially, the entry point function where we define, oh, this should be the address of the provider, and here it has. So it is. If you see here, we are calling the something called provider server here. So that is what it will be executing. It's part of our framework, and that I will share about it a little bit after in a few minutes. And here we have defined where is the registry URL for it. Along with that, if any authentication or the parameter is required, that'll also be that will be defined in another function, but the function will be called here. So so if someone asks like how we can develop plugins, so what I need to know before even start to learn the provider, we need to know, for example, if we want to manage the database, like I did a contribution for MongoDB, which I use for DocumentDB, also both built on MongoDB engine. So if you want, I need to know all the um, I need to know how I can use uh, API client for to manage in Go to manage the database. So that is the first thing, and then to use that, I need to know how to manage that using Go. The using the Go API client, which is Bison in Mongo, and I need to have foundation of Terraform also before that is more like a HCL language, like a template. Because if we don't even know that, we don't even understand how to build plugin for it. So after that, if we know all that, we need to learn how to what is Terraform plugin framework and how to use it. This is the currently most recommended framework, and then we have to we need to know how we can develop a local test environment and test it locally, because initially when we are developing, we need to uh, create a test environment, and yeah, as I said, and then I have to define the service API, and yeah, and then there is something called like a state management. So Terraform use state files. We need to where it stored the metadata about the state of the service we want to manage. So if we have, for example, deployed the database, it will store all information about the uh, database in the state file, and it will going to every time compare it. I'll show it later more. And then there's a schema. I'll talk about this all in coming slides. So the resource that we want to manage, and there is a data source, like we want to pull some information regarding some ID or security group or something we want to use. And then yeah, let me share more slides too. So on Go, if you say, okay, if I know Go, but how do I know how much Go I know to start learning? So basically you should know uh, all these concepts in the Go, starting from structure, how you can handle error, and know about pointer, how we can manage the memory, how you can uh, create how you can create or manage package or module in that, and what is like coroutine concurrency channels, and yeah, because if we are using API client, we should know a lot about JSON marshalling and marshalling also, and testing as well. Testing is like without it you can publish the provider, but we, as a good practice, we should add some test cases just like any other development application. And the in terms of resource cycle, if we look in the Terraform, like I said, it has a state. So but if we have not built anything initially, there will be no state, and then we are trying to, if we have provider, we're trying to build something, Then initially we run something called Terraform plan, where it shows if the state has nothing, and in your Terraform resource file you have defined the resource. Then it'll try to create the whole resource, like database cluster. It will try to create the database cluster, and because the state file is empty, and then after deploying creating the database cluster, it's going to add all information or the metadata about it in the state file. And next time we will run it, then in our resource file we have to, if you're doing any changes, then it'll show the difference by comparing the cluster from the local state file. The state file, I mean, it can be local or remote. In the production, the people use it in some remote state option. But yeah, that's so talking about again Terraform plugin framework. I think it was released in 2021, and it has some of those terminologies we should understand, which I will talk now. So something called Terraform provider server, which I said is the entry point of the provider and communicate with RPC. And then there's a schema, resource lifecycle method, and context handling, resource management, and import. How we so import functionality in import is something like if we don't have Terraform configuration for a service which is running, for example, that database cluster is running, was created manually, but now we want to manage it through Terraform. So how we will do it, and that should be defined in our provider Go code as well. I mean, it should exist in provider code if we are trying to develop that provider code. And then there's also a lot of type definitions, like in 32 and in 64, or can be like a different types for any uh, of the values we are managing through the API client. So when we are running, for example, like I said, database cluster, and when we try to get the configuration for it from it uh, through the provider, when we will pull the configuration, it may have different type than the Terraform supposed to have. For example, if the provider currently plugin framework, it expect all these int values to be in int64, but maybe, like I'm talking about MongoDB, I went to the MongoDB driver, which is like this bson API client. It stores them in int32, so we have to do those conversions sometimes, and if sometimes those are like value in a different format, and we have to convert them in map also a lot. So those kind of changes also we need to do in the type conversion. uh, so here, back to the option again, like here I told about provider server, but we have to call its parent Terraform provider plugin framework library as well. So initially, the how we're going to structure the code is it go more than some when we do go init locally when you're trying to build initially provider, and then this main.go, we're going to have a code like this, where we are just giving the basic information, and in the provider, in the internal provider folder, we will define provider, and based on how complicated your provider, you can create like other functions in a separate file. And for example, like there will be in internal you have provider, then you can have a client other directory also, uh, and then yeah, there's in provider we have to define our provider schema and resource, data resource. So based on that, whoever is using the templating HCL language, uh, the rules for that are basically defined here in our implementation of provider. So yeah, after understanding API, yeah. So in the schema on the front side, where the user of the Terraform, uh, if we want to see how the schema looks like, uh, we can check it through Terraform provider schema JSON. It will show, give a lot of information about the schema, and it'll give you the version of the schema, and the whole JSON kind of a structure here will come under the block. And this basically the schema function looks like on the high level overview. Like here we define if you want to use like API key, if it's required or not, or what will be the optional attribute we want to use here. Like endpoint should be essential and mostly API key for authentication. If you're not using any other like a user password, this should be required also. And and if we are building something in the cloud, we may have to define region, what region we want to use. Uh, yeah, so those kind of things will become part of the schema structure. Uh, so yeah. Now defining about the resources. So in resources, I will say the most critical part. Here we have shared like example of create, and in here we mention a logic about like how we will create the resource. So for example, I just give example like full resource. If we're trying to create a resource, and we should add like a diagnostics uh, function as well, and we call the API through our API client to create that resource. So for example, to create the cluster, if you want to define, and we're going to handle errors if we are not able to communicate via API client to the resource or the database. If, for example, if in my case I say, and so there are basically all the operations similar to create we have to define in the resource. They're also called like resource modeling, and these all these resources are stores with the resource ID, and it so when we do, as I said, we are creating, and we need to do read operation, and when we want to destroy that cluster or resource, we want to add delete, and but then there is something called update also, which in some cases will just update the configuration, but in some cases it recreate the whole, like in MongoDB it doesn't. I was creating the resource for updating the indexes, but index update doesn't support it. We had to delete them and we have to recreate them. So those all things, and the one more last part is like importing them. So importing them is also will be defined here. So the other part is data sources. Data sources fetch information without creating the resource. They are useful. So it's the smaller part. It'll only have the read part, and so information like in the cloud, we want to get the region from the some state file output, or AMID when we are creating some instance or something. So those kind of information can be pulled via data sources, and it can be defined in the separately as well. And Terraform has rely on the state file, which is considered to be state of truth, and state management rules are always perform read first before making any changes, and update state with API resource to detect the drift. We also need to handle any missing resources gracefully. So uh, the next part, the context handling, is also very important. If any user running Terraform want to will press it's for example, it's creating a cluster, and we'll press Control C. So how gracefully we are able to manage it shouldn't be in a we shouldn't be in a situation that we will live with half created resource. So that's what should be defined here also, and this is why it's one of the good advantages of using Terraform. So provider implementer need to take care of that as well. Or in the case, if the cluster is running but it uh, initiated creation but it's not completed, so we should handle the timeouts also in context handling part, and it can be defined here also. Something like that. So but in other than that, we have to define other we have functions like diagnostics and other error handling that is also defined if API has other errors coming up, so we need to return them also to the user in the Terraform in more understanding way, in a simpler way. Uh, and the other part, you have built all provider, you have tested locally. Now you build a binary and you want to publish it. So the process for that is you're going to log into the Terraform provider registry. You'll create a GPG keys, and you basically you need to have that code in your Go GitHub repo or some repo. And I logged into the GitHub repo, logged into the registry through GitHub repo. You need to give access to that, and you create a manifest JSON file, and you create the Go releaser file, and then you have to share GPG keys also with that. And after doing this one-time setup, after login and run in your GitHub, you need to create a CI/CD pipeline file, kind of a CI pipeline, where it has where it'll call this Go releaser also every time you're going to push some code into that. And it create a binary artifact where it basically go binary out of it. And you should provide both Linux, Mac OS, or Windows different release for that. And uh, after doing this once a time setup, when you log into the Go provider registry, it'll going to detect changes you are doing, and it'll going to update the release in the provider window, basically on provider page here where you have documentation. Also, we have TF doc. I think I have mentioned here now. But yeah, basically there is a TF doc uh, kind of this Terraform plugin framework support. So it can help you to automatically generate the uh, documentation on the provider page. So that is also good to use. And yeah, that's most about it. So here I have shared also like a flow of function when we run something like a Terraform plan, which resource uh, in the resource model code, where we have to define those functions, and it will go through all these process from Terraform resource plan change. Here we're going to check behind the scenes which uh, changes in the state file from the current configuration. If there's any, like, it will do something like going to do the diff. And yeah, so similarly, this is for the Terraform apply. Uh, so it's basically essentially going to call your resource related to those create, delete, or update functions. So these are not like separate function. Yeah, these are the separate function: create resource, update, delete resource. And this is part of like Terraform core. It'll going to call those, and from those it should trigger. When we are running the Terraform commands, it show from the core. It should call these functions. There will be a lot of drift issues when we are building it locally, and then there's a debug option in Terraform which we can do. It'll show more better optioning. So yeah, that's about it. And there's a resource I used for building Terraform provider, and this is one of the provider I have built. And the good thing is, if you want to use cloud native like OpenTofu, so this OpenTofu also can, if by building Terraform provider, you can also use the same in OpenTofu. I mean, if you contributed to Terraform provider, you can use the same repo and import it into the OpenTofu provider, something called maybe registry to that as well. So it will work for both sides. It's like a portable. So yeah, that's it from my side. Thank you very much. Should I stop sharing?